Hi students. So now I am going to tell you about the test procedure for equality of variance of two normal populations. Okay. So this is the only method we use when we come across two normal populations. Okay. That to variance. If you want to test variance for two populations, this is the only method we have to use. Okay. So that is nothing but F distribution, F test also we can say. So normally whenever we want to test hypothesis, so at the time we follow some steps. The first one is set up null hypothesis, set up H naught, that means null hypothesis. The second is set up alternative hypothesis, test statistic, level of significance, and the next is conclusion. Okay, so these steps we have to follow whenever we are going to perform any test. Okay, so you can use this level of significance in the third step, or else you can use here itself. Nothing happens in this. Okay, if you interchange these two steps, nothing happens in it. Okay, so in order to test the variance of normal population, which test we have to use? We have to use F test. Okay, so first step, what we have to do is step 1. So as I told you just now, so state the hypothesis. That means we have to set the hypothesis. So state the hypothesis. Step 1 is what? State the hypothesis. In this we get null hypothesis and alternative hypothesis. So null hypothesis, first one I am going to write. Null hypothesis, it is denoted with H naught. It is denoted with H naught. Okay, so the variances are equal. Why? Because here whenever we do any test, here we have to take that the observations or the samples or the populations we have to take, those are equal. Okay, so here we are going to test what? Variance. So that's why here what we have to take is the variances are equal. The variances are equal. So that means what? How we can write this one? That is nothing but H naught such that sigma 1 square equals to sigma 2 square. Okay, so this is null. What is alternative? Alternative in the sense that is opposite to null hypothesis, or else we can say that is a controversy for hypothesis, null hypothesis. Alternative hypothesis is opposite to what? Null hypothesis. So here what we have to take? Here we have to equal. Here what we have to take is not equal. Okay, so the variances are here also. The variances are not equal. Okay, so that is H1 such that sigma 1 square not equals to sigma 2 square. Okay, first step is completed. Now what is second step? Now step 2. So what is step 2? So step 2 is, here we have to write the test statistic. Okay, step 2 is nothing but we have to write the formula. We call it as test statistic, or else we can say calculate F statistic. Okay, so under null hypothesis, the test statistic is F equals to S1 square by S2 square. Okay, so here what we have to remember is Here see, note, or else since you can note the large sample variance. The large sample variance. The large sample variance is placed in the numerator. Is placed in the numerator. Okay, na? For example, here we are having two samples. Okay, so here see, sample S1 square is, if we say 10, S2 square is 12. So now which one we have to place in numerator? S2 square by S1 square. This is the formula at the time. If S1 square is 8, S2 square is 2. Now how the formula we have to write is S1 square by S2 square. That means what? Which term is greater, we have to place it in numerator. Remember, the formula will change according to the what? Numerical value. Okay, according to the numerical value the formula will be changing. Why? Because the greater term will be placed in the numerator. Okay, next step 3. So what is step 3? Here, determine level of significance, or else we can say what? Degrees of freedom. Okay, so here we have to use what? Level of significance or degrees of freedom. So step 3, determine degrees of freedom. Okay, so degrees of freedom is denoted with df, small df, or else capital Df. We can write df like this also we can write. Okay, so degrees of freedom. So here df1 in the sense what? df1 equals to n1 minus 1. Okay, this is for what? The numerator. This is for the numerator. Okay, next df2 equals to n2 minus 1 for the denominator. See, sometimes as I told you that according to the numerical value this formula will be changing. What is there in numerator, that comes df1. What is there in denominator, that comes df2. Okay, don't confuse. Okay, next is, now we have to do critical value. Okay, and the next is now to find the critical value from the F distribution using F distribution table. Okay, using F distribution table. Okay, F distribution table, we have to find the chosen significance level. Okay, so we don't know at what level of significance we have to find. Okay, depending upon the problem, here we have to fix the level of significance. Sometimes they may give 5% or else 10%, 1%, 90%, 95%, 98%, 99%, like that they will give, no? So according to that we have to fix here what level of significance. Okay, so next is conclusion. Step 4. So step 4 is conclusion. So if calculated value calculated value is less than tabulated value is less than tabu sorry is less than tabulated value, accept H naught, that means null hypothesis, accept null hypothesis. Okay, so this is conclusion. So symbolically we can write this one, that is F calculated less than F table, accept H naught, otherwise reject H naught. Okay, that means reject H naught means what we are accepting here, we are accepting alternative hypothesis. So this is the test procedure for equality of variances of two normal populations. Okay, hope you all understand. So thank you for watching, and for latest updates subscribe to my channel. So share with your friends so that they can also learn, and don't forget to like. If you like, the video will reach to the persons or students who are in need of this question. Okay, so thank you, have a nice day.